we took transformations again of sine graphs. These ones a little bit different in the fact that there might be negative theta. So there might be a reflection in the y-axis, okay, based on what's in there. So it says, we're basically going to go through, see if we can find a simpler form for all of these. That's really what an identity is. We're going to spend a whole bunch more time on identities. But we're trying to find a simpler form, kind of trying to simplify it. So there's this function, sine of pi minus theta. Express it in transformation form. So remember, in transformation form, we do anything to the y, there isn't anything. We do anything to the x or theta, but put it with theta having a coefficient of 1. So if I rearrange this is negative theta plus pi. So I'm going to factor out the negative, and then theta minus pi. That's transformation form. Back from the transformation unit. Okay. So now think about what's happened. We've graphed y equals sine theta for you. We want to reflect in the y-axis and then translate to the right pi units. So if I reflect this in the y-axis, this doesn't change. This goes over here. So basically it's going to look like this. This point goes over here. So it's going to follow this. Okay. Now I'm not done. That's why I use pencil. Okay. And now if I go to the right pi units, I should have done it all at once, because now if I want to move everything to the right pi, I just have to move this whole thing on top of the previous one. So pi units to the right, gets me there. This goes here. This goes here. So basically, it's equal to the sine function. So this equals sine of theta. So we just simplify that one. So the blue is reflecting in the y-axis, and the green is the overall final y equals sine negative theta minus pi. So how does the graph of that, pi minus theta, compare to y equals sine theta? They are the same. So that is what we can call an identity. It's going to be this for any theta, those are going to be equal. You can substitute any value of theta in there, and the left side will equal the right side. So it's just helpful to be able to simplify. If you have some expressions, maybe you'll have sine of pi minus theta. Don't keep it like that, just replace it with sine theta. You simplify that expression. And that's going to happen when you get to yeah.
When we end up doing the same thing for like cosecant,
you're not going to have to do, no, you're not going to have to for those ones.
In that case, just the reciprocal of the regular function. So you just take the reciprocal and then figure out whatever.
Yeah.
You can kind of figure things out based on if you have the reciprocal function, you can kind of draw the in-betweens and figure out where points are varying.
Yeah.
The points, there's like the relative vertices, that's the points of the maximum.
Okay, so next one, we graphed cosine. Again, express it in transformation form. It's going to look the same, right? Because it's pi minus theta. Okay, now let's practice our transformations here. So we're going to reflect this in the y-axis. What happens when you reflect cosine in the y-axis? Nothing happens. It's exactly the same graph, right? Now, technically, that doesn't mean all the points are invariant. because this point became this one, right? But you end up getting the same graph. So that doesn't change for the reflection. Now I go to the right pi units. So this goes over here, this goes over here, this goes over here. So now okay, what it looks like. What's a simpler equation to represent that blue graph? Without a translation. Negative cosine. Simpler, really, usually a translation makes it more challenging. That already had a translation, so we could keep it the same, right? And that would be just as easy. But this is equal to negative cosine. That's simplest, right? That's much easier to deal with than a translation again. Okay, so those are equal. Now you can think about this in terms of slowly. Okay, and then tangent, same thing. So this will be y equals tan of negative theta minus pi. Okay, so transforming this. Reflecting in the y-axis, so that doesn't change. So I'm just going to do the reflection first. This goes here, this goes here, this asymptote becomes this one, that becomes that, so the asymptotes stay the same. Okay. Then this reflected pi goes to negative pi. 3/4 goes to negative 3/4, etc. So you'll see that basically within each set of asymptotes, it's reflected as well. You kind of think about it that way. Okay. So you might think, oh yeah, that's what cotan looks like. No, cotan is in a different location, right? So, okay, so that's a reflection, and now we need to go to the right pi units. So here to the right pi, here to the right pi. Well, what happens? It's just everything's translated, right? So here to the right pi is here, so you actually get the same as after you reflected it. Okay. Now, saying that, so you could show that as tan of negative theta. Good. That's okay, right? But I kind of want that argument to be theta. We can't. So this, we could show it as tan of negative theta. What's another way we could represent this? Let me get George's stuff.
Negative tan theta.
Negative tan theta. Okay, because here's your original. That's also the same as reflecting that over the x-axis. This point here becomes this one. This point here becomes this one. So really, that's what we're looking for. We're trying to make that argument, that angle part, as simple as possible. Nothing done to it. So that's really what we're looking for. Although, I mean, you can do both of them, but most times you will want to make it negative tan theta. Okay, and then they're summarized there for you. All right, so these are identities that can be used to simplify trig expressions and equations. That's what we're leading up to in this next part of trig. These are not in your data booklet for IB, and they're not on your formula sheet for 30-1. We will be learning other ones, but those are helpful to use, but they won't be given to you. Yes, sir. Oh, sorry. Yeah, they shouldn't be the same there. They are reflections of each other. Sorry, thank you. And, oh, in the theta axis, I guess. And did I answer that one for close? I don't remember answering it. No, I didn't. So these are also reflections. Okay. So question 2 and 3, they were reflections of each other because of that negative cos or negative tan. Sorry, okay, so a little bit hard to see on your photocopy. These might be able to see it better looking at the board here. Okay, this is how you might think about it as well. Yes, sir? No, we said negative cos theta. So when the negative's out front, that reflects it in the theta axis. Okay, so you can also look at these, folks, by thinking about the unit circle. So again, this is a little bit hard to see on your notes, but you can see here I've graphed the terminal arm going to point xy, and there's your angle theta. Okay. So if that's xy, then, and we're finding sine of if that's theta, and we want to graph then pi minus theta, that will give us this terminal arm going from there to there. Okay, so that reference angle is the same as theta. So those triangles are the same. So if that point is xy, what are the coordinates of this point over here? Negative xy. Okay. So all that it is a reflection, right? The x has changed sign, y is the same. Okay, so think about sine of this angle here, we're looking in this triangle, is what? Sine over here is what? That's why these are equal. So there's no work to do on this. It's just to show you in the unit circle. So cos of pi minus theta, drawing your triangle, cos here, that's negative x. Cos of theta is x. So if we take x and multiply it, so this is x here, and we multiply it by a negative, we get negative x. This is negative x. Right? They're the same. Tan, so in this triangle here, it's y over negative x. So I'll do a t-chart maybe. Y over negative x. Tan here is y over x. We've got a negative out front. And you always show the negative, simplify it to show the negative out front. So they're the same. Okay, so now on your own, you're going to go back a page to the hand-drawn axes there. Notice how there are some other ones as well. So you'll see a little bit halfway down the page, you'll see sine of pi minus beta. At the bottom, you'll see cos of pi minus beta. So we've done those two. On the back page, you'll see tan of pi minus beta. But there's some other ones as well. So I want you to figure those out. There's an x and y axis. So really, there's this shown. So there's grid units, 1, 2, 3, 4. I would use 1 grid unit for each quarter of a cycle. So we would want 4. So I would just show my initial like this, okay, and then do the the first one is a translation left. Think of what graph you could replace that with, what's simpler. Might be not even sine, it might be a cosine. But that is how I just do a little sketch to help yourself. Okay, just use grid units of 1. 1 grid unit that would be pi over 2. You don't even have to label them. It's just a little sketch for you to help figure it out. Okay, and then you can check those answers on Schoology. Okay, that's where we'll stop for today. And then, as I said, we'll do transformations of tangent functions tomorrow and get into a little bit of the next stuff so that maybe Wednesday you can have at least part of the period for a review.